just want to deep dive into the flashback. Basically the 3 days, the two sessions which we had, right. One was very specific to containers. What is a container, and we did talk about how to build a container, and why we need a container and building it, and so many various other specific things which was required from a container world, and building it in a simple way, and how to deploy that container in a cloud. We also used registry and other things. And then we saw orchestration of these containers in the previous session, for specifically on the Kubernetes side, how it provides an interface for our workloads to be deployed, and from the how exactly it abstracts your hardware, and how you can manage your resources better, from a container and orchestrations world. And we saw the how to define these desired state through the YAML file, how we can build it, and different kinds of deployments, like the deployment and the service, how exactly you design it, and what are those object models we need to provide in that YAML, etc. So we saw in depth of those things, and we did deploy a specific application as well. um, but we went through most of these elements of the orchestration, and today I'm focusing on scaling, and how do we do deployments. And from a deployments world, nothing much changes. It's just the what are the various strategies, how exactly it happens, and how to drive these strategies, and where exactly these strategies are used. And definitely we will go back and see from a scaling perspective. I did mention last time that virtual kubelets is one of the interesting scaling tool, and we will see that. We'll deep dive into that, and I will also show you a demo just for the session. All right. I have been facing some network issues from last 1 week. And so I have a couple of things. What I've done is the recording of that demo itself, so that we can make sure that we use that as a to see the demo instead of doing a live demo here. I'm sure there would be some issues which I faced in one of the conference as well, in the RootConf. And while I was doing the demo, the demo did not work. Then I had to redo everything on stage. So it was really difficult. So I just want to make sure I show you the demo through a recording. Okay, so we went through this architecture, and I just don't want to go deep dive into it. We saw master node, how exactly it works, and then we saw how this worker node works with with the kubelet as a functionality. And I did give you this specific link where you can drive your learning on Kubernetes. You can start with day 1 to day 30, or even in between, the concepts and everything. This is an amazing set of the roadmap which has been provided by Burned Burns. So you can definitely understand how exactly Kubernetes is there, and different set of practices which is available out there, and obviously understanding operations of it. Given this, I did touch upon deployments, but today it's more about understanding how exactly it works, and how different strategies are available now, and how Kubernetes does this. And to give introduction to deployment, it is nothing but rolling updates and rollbacks. So it's nothing but, if you have any kind of production, either it is traditional production or in a container world, you have to deploy your app, and if there is some issue, you have to roll back. And there is a way to pause your rollouts as well, which was not there in traditional method, because once you have rolled out, if you have done kind of changes, rolling back was a challenge. but something which is being provided by the by the Kubernetes inbuilt. So this is one of the most important element of any orchestration tool. So Kubernetes most important feature, and it is built in fact. And we did discuss about replica sets. Replica sets is nothing but identical copies of the pods which is available. These pods are nothing but a group of containers or a container which is out there, and it can run on any of the worker nodes which is there. So you can see that there are a couple of worker nodes. Depending on how schedulers plan this execution, it gets deployed onto the different worker nodes. So basically these the version one version, forget about versions, the pods are there in these worker nodes, and when you um, come up with a new version, it's slowly getting replaced. The version one is getting replaced through a version two. And how it exactly does that, we will see through a demo. Not just a demo, through um, how the whole structure is available. To understand that, we need to understand how exactly the deployment works. So it's very simple. We created the YAML file, we defined the deployment, we tell which is the how many replications of this pod is required. We give the image, what the image it has to be, what are the container image it has to be in that YAML file, and hand it over to the API server through kubectl. Kubectl is nothing but, we did discuss about, it's a client, it's installed on your laptop, and you're talking to the master node via the API, through API servers, endpoint via the kubectl client. So you hand it over, and once you hand it over, the control manager takes it, decodes it, gives it to scheduler, uses exit database to plan the scheduling, and does the deployment to kubelets. So this is the discussion we had last time as well, when we saw a demo of all these things as well. Nothing changes from the way we deployed. The only thing which you need to remember is you can do four kinds of deployments, right? One is this: you're creating it fresh, right? You're creating something really new, and you're not the application does not exist in your Kubernetes cluster. From a production perspective, your first time you're creating this in a production, so this is simple, straightforward, what we did last time. And then there is an update. So you create a new version, and you roll out the new version in a different fashion. I'll talk about that, how do you roll it out. And then there is a rollback. And when I talk about rollback, it's more about if you feel there is current state of the deployment is not right, or the state we deployed is wrong, we need to roll back it to the version back, the different tags of your container, or the version of your container. So you just need to update your YAML file, or using kubectl command line, you can do that. And then it's about scaling. Scaling, you don't change anything. It's just that you're creating a replicas of these pods which is already there. So you're scaling through the already existing services, right? Already running pods which is already there. You're adding more pods into the Kubernetes cluster. So this is the four ways you can do it. And by the way, um, you know uh, how to do it. And also, a couple of things I missed out at the start of the session was, there was a couple of questions last time asking on how do we do the monitoring, and how do we do the debugging of Kubernetes cluster which is out there. I have posted it on my Twitter handle today morning. There is a couple of 9 tools which is out there, and you can take a look at it. And also I have posted there how exactly to do deployment strategy as well with all these things, and how you can use those YAMLs. So coming to the strategy perspective, so this is an amazing video from Burns. And by the way, you can get the this video is available out there with if you go to that my link which I have provided, and if you go there, you can actually see the list of videos which are there, and this is one of the video. I'm using the same video and same concept to explain you how exactly this works. Remember, while doing the deployment, we give the image which is version 1, so I'm pointing it out here, and then there is a load balancer through a service. So through a service, we are attaching the load balancer out there, and then there is pods which has been deployed. This is version 1. So the one which is there in orange here is the version ones of the pod. And through image 1, we have used the deployment kind in our YAML file, and we have deployed it. And now you want to you know update, right? And you want to go to the version 2, and what you do is you change the image version 1 to 2 and reapply. So when you do the command as apply or kubectl command to update the image which is already available out there, then there is a way to update this one. What it does is there is two concepts in in deployments. One is liveness check, and the other one is readiness check. So when I talk about liveness check, it is to make sure that we need to restart your pod on. That means all the containers or not, whether it is in running state, whether what it is, what is the state of it. So liveness check usually checks for your service. It's basically checking for the pod whether it is active or not. And readiness check is whether it is ready to take in the request, or it's basically is it ready to serve. So these two checks has to be done for making sure the state of the pod, the readiness of the pod for going live. So basically, when something which is active with on the load balancer, it is running, and you change the image version 1 to 2, when that happens, version 2 of the pod is deployed onto any of the nodes. It does not matter for us. It is the role of the scheduler which actually plans that. It just deploys it on any of the nodes, which is in green here, and it does two checks. One is liveness check and the other one is readiness check. So both the checks passes. Once it is passed, what happens is it goes to the load balancer and it registers that to the load balancer. This all these three pods are still running, and this new version of the pod is coming in, and then it gets attached to the load balancer which is there, and still this is serviced, and then slowly it removes this specific pod out of the load balancer. As mentioned here, there is a grace period of 30 seconds, because there will be a request which it will be serving. So the request will be cut off, but the request which is serving in this pod will be taken care. Default is 30 seconds. You can actually go back and change it, but default is 30 seconds for sure. So similarly, since you have not changed the number of replications, the version 2, 3, 4 gets added, and it does through this readiness check and liveness check. So let me go back to my other slide, which I was showing, right? It's the same way. So there is version 1 and version 2 comes in. The version 2 is verified with liveness check, readiness check, and when it is ready, then it pushes through the load balancer or the service, and then version 1 is still there, and the version 1 slowly cut off from the load balancer, and after the 30 seconds grace period, the version is moving out, and then version 2 is taking the space of that. So that means it is a slow replacement. It is not like replacing all the things. So at this point, right, you feel if there is version 2 is already been served, and version 2 is getting in place of version 1, and there is already a version 1, if you see here, which is already running. At this point, if you feel right? There is something wrong with your version 2 and you feel there is a problem, you can pause the rollouts. So here is a feature where you can pause it. Everything is is through your kubectl CLI, right? Everything is working through a CLI, and you can pause it through CLI. You can figure out the status, and you can find there is something wrong. You can pause it. You can revert back by giving the old image size, old image name, and do it. I've posted all those commands, everything in my Twitter, so you can go back and get all those details. So you can easily do this activity, right? You're changing these you're just running a kubectl command, and it pauses the rollout, and then you can revert back to the old version, and you can push it to the new version as well. So everything is via the YAML file which we have defined and the kubectl which is there. So you can manage everything through those two items. You are not actually you're going and doing something on the hardware or killing something, doing a couple of activities. Everything is managed, easily manageable, and it is managed through the client and the YAML file which you have designed. So let me go back to the study. So this is how it works, and this is how deployment works, and it's pretty straightforward. And as I told you, Kubernetes is a heavily declarative tool, right? And deployment kind is a declaration. It's a declaration which you do, right? So the strategies also can be done through declaration only. And all you need to do is to change the metadata, the name of the metadata, and all you need to do is the service, add right set of things on the service to access the right set of pod. So given that, there are a couple of strategies which is available out there. One is ramped strategy, which is Kubernetes default rollout method, which is we have already seen this. This was the same thing which I explained. Old pods will go down, new pods come in, and that's how it actually builds into all the version 2 through slowly removing the version ones. And this is and this is very, very useful, and it is not taking the cluster down. The cluster is always available, and the service is always available either as version 1 or version 2, but slowly moving towards the version 2. And that's how the strategy works. And this is by default. By default, this is the strategy which is available out there. And we did a demo of this last time when we did Kubernetes cluster and building an application and pushing it out there. All we need to change in that demo was the metadata, and how we it's basically the metadata with where you give the canary deployment and go to your service kind, and in the YAML file add the right set of information, what service which is available for the canary deployment. What is canary deployment? It's very simple. You're releasing it to a specific set of people, and only the new version is available. The new version is available on a specific service, and it is only few people can access this, and you are giving it through that. And it's again, it's the way to deploy it by identify more problems, and you're not really releasing it to the customer or something. Probably a group of testers and group of people who can go back and test this out, right? And that's what canary deployment is. And this is A/B testing is another version of canary deployment. It's just that making sure that customer is available out there. It's not the small group of your own organization or small group of people who can really test it out, but it is real world customer business business goals which is required to be tested. And it is the distribution is basically available for people with specific headers and with the cookies and geolocations and other things. So you can define all these things on the deployments, and uh, everything is controlled by a YAML, and you're defining it in the metadata of the deployment kind, and then the service of that specific kind. So this is how A/B testing works. And then blue-green deployment is again, this is where you are putting the new version on the production, and it is only available to only set of people, not set of people, it's not available to anyone else apart from your team who is testing on the production itself, and then moving the one pod to another, killing the other pods and making it all available to version 2. So how this works is very simple. Uh, it's in a very similar fashion of Canary deployment, but this is only available for the people who are testing it in, testing something in production and other things. You want to release something and see how it works. So only for set of people are available. So it's very simple, right? When we are doing such kind of deployments, what we used to do in traditional world, we used to go and create an infrastructure for specifically deploying these kind of applications on the new feature, and give that access to the new feature to the development team or the testing team, or the some of the customers who can test it out and give us some kind of input. While the production was isolated, production was running, and production was available for the customers, you used to create a separate environment for yourself. So instead of doing that, instead of building that out, the way Kubernetes is providing you an option is, there is an infrastructure which you already have. There is a production which is already running. On that production, if you can isolate couple of pods on that infrastructure, and through the service, through the deployment kind which is provided by the Kubernetes, uh, just by adding all those details and running it, you will be able to separate it out and use it, use that link provided by the service, or the IP address on the service which is available there. So basically this is how exactly the deployments work, and end-to-end deployments work in this way. So coming to the this was about we how we build how we build up product new, and then push the products to the Kubernetes cluster through various updates. I want to talk about the virtual kubelet. Very interesting. This is about scaling. So how do we scale virtual kubelet? It's about serverless Kubernetes. And when I say serverless, there is, don't assume that there is no infrastructure. There is infrastructure, but it gives you a virtualization. It gives you a feeling that there is no infrastructure, because I'm not managing the infrastructure. I'm not spinning up an infrastructure, but I can scale my applications. So that is the abstraction layer which Kubernetes virtual kubelets give you for Kubernetes. And obviously, when it comes to about when we are talking about serverless, it's obviously about getting started faster, and you are actually managing the consumption, and you're paying less for that consumption. So that is what the virtual kubelets are all about. But before I deep dive, we did discuss this, and this is very important from our understanding of kubelets. We did talk about master node, we did talk about worker nodes, but very important, interesting is you need to understand what is the role of kubelet. The kubelet is responsible for running the pods in the worker nodes. And if you see this diagram is the same, and we have been discussing about it in last session, this session, in both the sessions. So it is very much important in terms of running a worker node. So how usually, usually how does this work in a real world scenario? So in a real world, when you spin up a cluster, what happens is there are different nodes which gets attached to the Kubernetes cluster. And these nodes Basically what happens when it creates a new node and installs all the required binaries, required infrastructure on that node, it registers itself to the master node. In any client server model, any master slave, every client register itself to the master. So even in this scenario, the in the node is actually registering with the master. But when it comes to virtual kubelet, it acts as a, you install that binary and you expose that in such a way that it also registers itself as one of the node. So it's for master node, this virtual kubelet, is acting as a node, which is, where it can deploy or where it can talk to. So the control manager, the API server, can talk to this virtual kubelet as a node. So it is registering itself as a node. And as we talked about, the kubelets is basically about the pod and container operations. So it is taking care of the container operations which is out there. And you can see it manages the node conditions, get the details of the pods which is running on the virtual kubelet. uh, it's nothing but the kubelet's role is that, and creating pods, updating pods, managing the operating systems and the capacity and everything. So to give you a complete operations of a kubelet function, these are the things it does. There are a couple of things which are not available on virtual kubelets. Obviously, there is no screenshot of that because the virtual kubelets innovation is happening at really fast, and I had to remove that slide. But the real functionality of kubelet function is doing all these kind of activities, and we did discuss some of these activities, right? Container, it gets you the container logs, the containers which is running. It creates, pool for changes if there is a new set of pods which are supposed to be deployed. It takes care of the volumes, it takes care of the liveness and readiness monitoring which we talked about. So a lot of things it is taking care of. And the most important, the control loop, where through asynchronous it is taking care of whether actual state versus desired state. If desired state and actual state are different, it is actually going and restarting stuff. So all these functions are available on kubelet, and this is what a virtual kubelet also does. It is not everything available on virtual kubelet, just remember that, because it's still under development, and couple of things it can't do and couple of things it can do, and they have been innovating on top of that. So just remember, not all the operations which a kubelet does, a virtual kubelet will not be able to do. And virtual kubelet, as I told you, just remember that it registers itself as a node, and then it is available for spinning up the pods on its infrastructure. So that's what it gives impression to the master node, and master node is just holding the data. So it can be installed anywhere, and you just need to be able to reach the Kubernetes master, and it can be installed anywhere. Okay, so given that, I just want to talk about a scenario and how exactly this all fits in. There is a production of cluster, and you have running couple of microservices. Obviously, it is available, and there is a reliable service running in, and then there is auto scaling structure is all available out there, and there is a lot of traffic which has come in, and through this traffic, there is the microservice, the cluster, the Kubernetes cluster is not able to handle the traffic which is in. So what it does is the virtual node, which is nothing but a virtual kubelet. I'm just explaining this in terms of Azure Kubernetes service, but this can be used anywhere. Virtual kubelet provides a connector where it gives an impression that here is one more node where you can deploy these pods at the certain threshold of incoming requests, and thus it gets connected to any of the infrastructure. I'm just connecting it to Azure container instances, but you can connect to any of the infrastructure which you have and run these pods there as a simple single pods and run it and manage the scale. So there's a request, there's you are using Azure container instances, and it is connecting and it is scaling. So since Azure container instance deployment is unlimited, imagine the power you have just got it. So you have traffic coming in, and through this virtual node, or the virtual node which is attached to the master node as a one of the nodes, through that you are actually deploying a number of pods for scale, and you're paying only for the pods which has been scaled, and it gets killed once the traffic is down, once the threshold is less, right? So that's, you're only paying for the consumption. That's why I did call about serverless, and that's the main reason why I even said that it's fast and other things. um, Given that virtual kubelet is a open sourced tool from Microsoft, and it is obviously as I told you, serverless container platform. It is today a CNCF project. It got it was part of the CNCF project from 2018, and it's some of the use case, and this is a use case even I talked about, and I'm going to show you a demo of this, where there is a traffic which is coming in, and once the traffic comes in, the connector, the virtual node, through virtual node, we will see how exactly these container instances can be spinned up. So this, I am using Azure Container Instance. You can use any of the infrastructure and install your connectors there, and make it as a through virtual node which is installed on your master node, gets connected to this specific connector, and you can use it. So it's all defined in the YAML file, which I told. So Kubernetes is all about YAML file, the object model, where you define the operator for for virtual kubelet, and you define the structure, and then you can make use of the nodes and to scale your application. So let me show you a demo. In fact, this will give you a very specific information. So uh, I have a website where I'm going to hit that website with, almost, around 10,000 or 10 million, I don't know, some request, which is going to be we're going to hit that request, and we'll see that, there will be a lot of, pods getting created on the container instance, and you can see how it is actually scaling. So I'm just playing this video. I hope you see this. Is it visible? And
Yes, Vivek, it is.
so this is my website, in fact, which is there, and he is,
Uh, yeah, it's fine, Vivek now.
yeah. So sorry, my network is having some issues, so that's why I have to record it. There is a, this is the, I want to stop here because I want you to see when I do a get node, right? And I get a list of nodes which is available, and you can see virtual node, ACI Linux is one of the node which is got specifically to the my um, master node. It is attached to it as one of the nodes when I create a new cluster. So if you remember, while in my last session, I did create a cluster with virtual node, and we did see that it is displaying one of the virtual nodes. That is the main thing which I showed as well. So that's three are normal nodes, and that one specific one is the virtual node which we did, and then you know um, we will see the pods which are running. Okay, so there are a couple of things. So the online store, and you can see Prometheus, and even the Grafana is installed, and online store we have only two pods which are running for the front end, and the other is also one of the counter online store counter, right? So basically now what we will do is we'll see the services which is running, and there is a couple of services leaving out the Kubernetes, okay, the external IP and all those stuff. So let's go back and show you. This is my container. So basically, if you see, there is only 3 container instance which is running as of now. And if you see the 3 container instance, and if you see this dashboard, right, this Grafana dashboard, there is only main running is 2, where we are trying to run specifically 2. The reason why I don't want to do a live demo of this, we are running it in various window, and it's we are using Hey command. Hey is a Go programming tool to generate request onto your application. So we are generating a huge amount of request. So it's basically an open source tool. In fact, we will see it on GitHub repo as well, where you can access this. This is how you can actually test it out. Like so we'll see the Hey GitHub repo. So you can use this tool to generate requests to test such kind of scenarios. So it's a open sourced, easily generatable. Just go to that link, and you'll see that it's a load generator. It's an amazing Go tool, though. So I think we've just started the services, and you can see that a pod number increased from 2 to 5 now. And you can see there is a request coming in the Grafana. And most important thing about this demo is, obviously, um, we have this is set to the last 5 seconds, refresh every 15 minutes, so not 5 minutes. So we change that out. Anyways, now we can see there is pod running. So if you come to the the ones which I was showing you in Azure, the container instances, you can see that from 3 to 44. So the moment we started the hitting that service with so much of requests, with the load generated, you can see that the number of container instances starting on the front end of the online store is 44, from 3 to 44. It just took some seconds for us. And that is the power of using the virtual kubelet in this scenario, right? You are actually using the infrastructure which has been provided through a virtual node which has been attached to your master node, and it just increases the number. And you can see how exactly this increase is happening, and it's pretty fast. And if you see a couple of things, there are so many pods which are running now and it is mapped to the virtual kubelet. So this is a demo which I wanted to do. And by the way, this is how you can execute the service. Let me take this ahead. It is gone to 54 now, and obviously we had to kill all the things to make sure we don't get charged a lot. And we have a couple of only items. So I'm just taking this further, and it will slowly kill all the pods which were running. The moment we kill, we reduce the traffic onto the server. So this is how you can do it. And let me go back. So this is how you can do the virtual kubelet thing. It's basically create traffic. There is a threshold. You can all define everything in the YAML. And once you've defined that structure, it is being submitted to the cluster, and cluster is waiting for the threshold, and then there is a threshold, and then there is certain things which you can run in any infrastructure, in fact. And you should just install the virtual kubelets on the master, and also on where you want to expose the infrastructure, and connect that with the master, with the API, with the Kubernetes API, right? So given that, we have already seen this, I just want to take questions if there are questions here.
Yeah, sure, Vivek. Vivek, just before we start the questions, I had one question for you. You referred to the that Azure container instance, right? That is like, if I try to explain, it's like a registry of containers, which where you have defined your particular image and it keeps on spinning them up based on as your load increases,
No,
right?
it's just the container engine available for you to run containers.
But where is it getting? So the container image is getting pulled from some registry within Azure, right? So you have to define it, that from where am I
Yes,
taking
yes,
it?
yes. See, those definition, everything is defined on your YAML through the YAML
Mm-hmm.
file, right? I mean, where you've defined last time when we saw that example. Let me pull that out. Let me share my screen. So this is the code which we saw last time.
Yes.
And this is where we defined the thing, but
The
you can
image
also
from here.
define the image registry. This is actually the image registry.
Yes.
This is image registry of Microsoft, which is available. But once you define it here, and here you're also defining where it has to run. That is, you can actually add the virtual kubelets, virtual node uh, threshold and everything in this specific YAML itself. And this doesn't change. Nothing changes in your YAML. It's just that you're letting it know in this YAML file that when this threshold comes in, number of traffic comes in, please run the next set of pods on any infrastructure which is connected to the virtual node. So I am using the Azure container instances as one of the connector, but not exactly the same way you will be doing it. You can do it on any other infrastructure, and sometimes the scenarios, use cases have gone to IoT as well, where I have only a container instance and virtual kubelets binary running on that, and it is getting connected to the Kubernetes infrastructure, which is running somewhere else. You can run a couple of pods on the specific virtual nodes. So that is how the use cases are, and there can be more use cases which is brewing as well, as I see the growth of it.
Just one question, Vivek. On that YAML file, you have defined the CPU in a power. I think what I remember was, and please correct me if I'm wrong, you're defining the percentage that if it crosses this value, you should spin up a new pod, right?
Yes.
So, but how do you specify that should be a virtual kubelet? Can you just show that particular,
Yes.
if there is a particular config? I'm trying just to understand that. So I'm sorry if I'm repeating the question again.
No, I'll show you. I'll show that information. Just give me a minute.
Yeah, please take it.
But
We have a couple of questions. We'll come to them one by one.
yeah, go ahead with the question. So I'll be answering and I'll get this.
Okay, fine. Um, just one sec. Okay. There was a question from Vamshi, which is that if you want to deploy it on a specific pod, uh, is there any capability provided by Kubernetes?
A specific pod?
Yeah, if you want to deploy the app to a specific pod, is there anything Kubernetes provides? Or a node?
Node is yes, but I don't understand from the pod perspective, because pod is anyways the containers. So
I think he meant node. That's what Vamshi meant, probably.
yeah, no, yeah, that is available. The So that is available, right? I mean, like it's a simple, on specific node. If you want to drive anything, talk to kubelets. So how do you talk to kubelets? Via your YAML defined, going into control manager and then talking to the kubelets. You can also use kubectl um, through API servers. You can obviously, uh, it's all talking to the same way, the way it works, but it is through that channel only. And by the way, for your question, I'm just sharing the screen and showing you this. Can you see this?
Yeah.
So this is a YAML, simple YAML. So here you are defining node selector with type virtual kubelet and tolerations and other things which you can define. So basically, this is how you can define it. And I'm this is an example of how I am using like the ACI, the Azure Container Instance for running these example. So it's most of the things in Kubernetes world, it's all there in the on the on the YAML side, and it's just that to understand how to define these things in the YAML. So that is the key for learning Kubernetes. And for the question of the other person as well, the pod, as I told you, right, there's a pod is there, and anything you want to run something on the pod, you can also define it here.
Okay. There was a question on the, there was a, I think, very valid point from Udham that when we are talking about deployment strategies, Udham was gracious to point out that, if we do blue-green deployments, the hardware requirement is actually twice the original one, because you're actually having a separate kind of, if I use the whole, a separate, DR hardware or separate passive site being made. And I actually had shared a couple of articles which talks about deployment strategies just for further reading. And so there's another question from, I think, okay, I'll take the question from Ashish first. He talks about that if you want to deploy function as a service on Kubernetes, is the answer kubeless or is there anything else?
No, there are many things which can deploy. It's all deployed based on the the operator and other things. So let me share OpenFaaS with Kubernetes. So there are many open FaaS set of tools. I'm just giving you one example with OpenFaaS. It's just the way it is getting deployed. You're just running create YAML file or the other thing which is required on top of it and running it. So I'm just posting it up here. You can see that. There are many open source tools.
It became a direct message. I just posted for the whole audience. Wait one
Oh, sorry. Sorry. I've just posted the link there.
Yeah.
So you can, you can figure that out. It's basically you are deploying all the required containers or required structure, what I call it, in the Kubernetes services or in Kubernetes, and you are actually using that service. So nothing changes, it's like deploying an application on top of Kubernetes. That's it. Anything like it's just an infrastructure abstraction on infrastructure, right? So anything you're doing on Kubernetes is nothing but you're installing something, and the way to install is always either through an operator or through a Kubernetes YAML file. So that's the simple way.
Okay. There was another question from Kiran, which is that, is there an automated way to scale down with traffic in virtual kubelet? I'm
To
trying to
scale
understand.
down the traffic?
Yeah, scale down with traffic, he said. Kiran, would you like to elaborate? See, we are using virtual kubelets to address the sudden requirement of an increased load. What are you kind of actually referring to here? Kiran, are you there? Okay, if the traffic is reduced, then we don't need the additional nodes. Okay, so yeah, what his question is that, okay, I cross the threshold, I introduce more virtual kubelets. Then once the threshold goes down back to its normal, are those instances automatically discarded? That's the question I think he has.
Yes, definitely. And that's the purpose of serverless Kubernetes, right? Serverless concepts itself. And and it does virtual kubelets, it does. And I have a demo of that in the RootConf session I did. I have a proper demo. I know there was some glitches in the demo, and I had to completely redo there on the stage. But you can definitely go through that demo. It's available on YouTube. I think so. I think so. You have the link.
I have the links.
I'll post it.
Yeah,
so
I know.
it's
I have
basically
subscribed to your channel yesterday, so I have the links.
Yeah, so there are. I've done
link.
that specific talk, and it has the demo out there.
Okay, this is a bigger question. That's the reason I kept it for. These are more interesting questions. So it's a question from Sanjay where he talks about, see, we have different deployment strategies like say Canary, Blue, Green, A/B testing. Now, he's saying that there are many tools for these. So some tools are based on ingress controller, some on service mesh. So for these below use cases, which tool would the audience or you suggest? So I have a relatively small cluster.
You mean to say tool? I think you are referring to CI/CD tools.
I believe what he's talking about is probably the deployment strategy. Is that correct, Sanjay? With the
no, there are several tools like vCloud and Flagger, and I believe CloudBees also had Jenkins one.
You're talking about
CLI project
CI/CD
that they
tools.
created.
You're talking about CI/CD tool, yeah. So I would go with Argo CD, right? I mean, it's you're working with CNCF tool sets, and I would go back and use Argo CD because it's been adopted by CNCF. It is open sourced, and now it is a kind of in a project mode. Don't worry of the rest of the things, because if some CNCF has adopted it, that means it works with all these different set of CNCF.
But in CNCF itself, I'm sure there will be more such tools, right?
No, I don't think so. They have
the list is very huge.
CD.
Spinnaker is also CNCF project, right? Or is it not?
No. Okay. Spinnaker is also part of Spinnaker is also there, but I don't think so. It is part of CNCF.
Okay.
So what I see is Argo CD is only part of CNCF. Just check it out, because that's what I know. And
so it can do A/B testing, Canary deployment.
Yes, and it is a project which has been adopted and to support Kubernetes, and that is the main reason why I also feel Argo CD is the best, because it is being developed on top of Kubernetes and it is being used for Kubernetes, right? And it has been adopted by CNCF, so I should trust them to help us in driving it.
So you're saying Argo will be able to handle both the small and large clusters, right?
Yes.
Vivek.
Definitely. I think it's a wonderful tool. While I haven't done much on that tool, but I've read about it. I've seen some demos. It is still
because some of the tools are very.
But yeah, obviously Spinnaker is there. Spinnaker is there. The other tools like even Azure DevOps is there. You can do that through Azure DevOps as well. And I just there are tools. What I would suggest is, as an architect, while you're choosing tools, have your role perspective, because sometimes what happens is there is Jenkins versus Go CD. Even Go CD, ThoughtWorks Go CD provides you all these functionalities, but when it comes to continuous deployment and continuous delivery, I want to go with specific set of tools, and not go with just the Jenkins, right? Jenkins was designed to be a CI tool than a CD and CD tool, right? So I preferred that than this. And so as a, probably an architect, just make a decision by seeing some of the features. But I would urge you to check Argo as well, Argo CD, so that it solves the problem the way you want to solve it. Else you can obviously have Spinnakers and other new tools which is really supporting all these things as well.
This actually kind of leads to the same question we were discussing today, Vivek, just before we started. That when we look at tools, it's if, as I think Sanjay had very fairly pointed out, the CNC landscape page is now actually a marketing gimmick rather than anything else. You go there, you will be overwhelmed, and somebody who's starting off, like for example, today, any one of us comes with a problem that I want to choose a CI/CD tool for Kubernetes-based deployment, and everyone is scratching their head. Which do you choose? Because we might have a set of requirements, but how do I understand that these set of requirements are best fulfilled by this? So in that case, what we can always look at or look to share is that, okay, we had this and this is how we solved it. So it's like learning from others' experiences. So what Sanjay is talking about is absolutely right.
What I would see, the way I would choose is, I have access to Azure set of services, right? As a company, Azure services are available to me, and I would go back and think about using Azure DevOps only. If I am doing something in production, running something, because I am sure that Azure DevOps will work with Azure services, right? So as in, if I'm doing that way, but if you're using different cloud or different kind of structures, thinking that way, that way, where it's also extensible, right? Your CI/CD tool strategy is not just fitting to that specific thing, but it also fits to the larger definition of your org.
Okay, that's interesting. Sanjay, there was another question from you. Would you like to discuss it with your mic on for the virtual Cubelet one? Or you want me to read it out? Okay, I'll read it out since he's probably on.
Sorry. There's a TV going on, cricket match. Okay, so my question was, you created the Azure container service, right? Like each container point maps to a K8s node. Is that correct? In the Azure container service?
Sorry, I can't hear you. There's some disturbance.
Okay. So the question was, each Azure container service that got created when you were showing the demo, that's basically a virtual K8s node, right?
Virtual Kubernetes.
Yes, virtual Kubernetes. Yes.
Okay, so
it's not virtual. It's not virtual Kubernetes. It's basically, what does Azure Container Instances provide you is a container engine available to you to use. And what you're doing is you're taking one of your containers and deploying there. So pods are nothing but a set of containers. So you're taking that pod and deploying on the container instance, which is being provided by Azure as a service. So it's a PaaS layer. So it is.
Okay, I got it now. So basically, the containers that would run inside a K8s node itself, those containers are now run inside the Azure Container Service.
So the PaaS layer, the beauty of PaaS layer is, you are not really worried about what is that infrastructure it is running, what is that scalability of it and other things, because it's going to scale anyways, and it is unlimited. So you can keep deploying your containers there. So and you are only.
I thought that those containers are K8s node itself, and inside them you deploy.
No, you're not deploying any node.
Okay, got it.
And I think to add to this, if I have to give a like for like, I know it may not be, but say a Fargate by replaced by a ACI. Say again, hypothetically in AWS, say if I'm doing this on AWS, so something of that sort. Okay.
By the way,
Many
virtual
things.
kubelets, let me share one more thing. Virtual kubelet supported platforms. There are a
Yeah,
couple of platforms which is
yeah.
it supports. Let me give you that. It's called
So is
providers.
it
By the way, I didn't talk about that much because there are only very few providers available today, and I will just share that link here so that you can create more providers as well. So I've just shared the link there for people to go back and read about these different providers.
in
You
the
can
last
create your
session,
own.
someone has asked this question, right? How to add extra node to a K8s cluster, and you answered that virtual.
So this is one way
What
of
would be
doing
the
it. This
answer?
is one way of doing it. The other one, I did speak to Kiran after the session. We had a big discussion, and there are other ways as well. The obviously we did discuss that as well. In fact, that was via the CNI interface, right? The
Mm-hmm.
which has been provided, the network interface. Through network interface also you can do that.
Okay.
I think different. I did provide all the documents to Kiran. I think if he's available here, he can talk about it. But he's working on a very specific problem. I think that's distributed Kubernetes, and very interesting. So I was just having a chat with him all through the last week, and he's been researching a lot on that and building on top of that.
Well, Kiran's mic is not working today, so unfortunately, he'll not be able to share his thoughts. But I think we can follow up on Kiran for an interesting session on what his discoveries were on this side. I think I'll reach out to Kiran. Okay, there was an interesting question from Udham, which is like, we were just talking about, all the CI/CD tools where Sanjay was saying that you have Jenkins, Spinnaker, Flux, Argo, so many things. Even I think Tecton is there from Red Hat also, the same thing. So Udham saying that you have continuous delivery as a service, and he's talking about harness. So Udham, would you like to share your thoughts, anything? Because I would like to hear a bit more if you have anything on those lines.
Yeah, actually, so this is so Utham this side. So yeah, so this is a tool basically I discovered recently. So what they have done is basically what's the traditional way to set up a pipeline? You spin up some instances, you install tools, various tools, integration, all those things, monitoring tools, and continuous deployment tools, and you create a chain, make all the tools talk to each other. That's how you basically, that's a traditional way of creating a pipeline. So what harness tool is doing is they are utilizing Kubernetes as their engine. So what they do is they have a very complex set of deployment files and all those services where you just have to select which tool you want. So for example, for your source code, you can use Bitbucket, GitLab, source code management. And for integration, you can use TeamCity, Jenkins, Bamboo, whichever you want to do that. And similarly for monitoring and logging, for monitoring, you can use Grafana, Prometheus, App Dynamics for logging, Elasticsearch, all these kind of tools basically. So you just need to select. And on the basis of the selection of your tools, you just click button in their website, and it will gonna deploy all the tools for you. And the job of you will be just create your source code and just trigger that. So there is a various trigger points as well where you can like how that basically that pipeline in that harness tool will gonna start. It could be timer based, or it could be some webhook based way based. So if I just give you a brief high level view, so basically it will just gonna deploy all the tools which you select. So, and it will gonna just right from there you can use that chain of tools as your continuous delivery as a service, rather than IaaS or PaaS. So all these things like that. So if I go into deep, it will gonna take a huge time. So just so that this is just a brief introduction about that tool. And the good part is you can include any kind of tool or any kind of cloud also in this. If you have your infrastructure on AWS, just select, give your credentials to this tool, and this tool will gonna just start talking to your AWS, Azure, or GCP, all these things. So that's what this tool is doing, CDAAS.
That's a
Yeah,
very interesting.
I think rest of the, I think Sanjay also pointed out, there are various tools which which has a similar which does a similar work, and everyone provides the continuous delivery as a service, including the Spinnaker, the rest of them, like the harness is also one of them, and even the Azure DevOps. Everybody is providing it as a service, so that is definitely out there, and I think it's a pretty interesting tool as well. I know I have gone through it once, but it's also an interesting tool to study, and it does give you all these kind of deployment support which we talked about.
I think we can probably for the next session, based on our availability or availability, Vivek. I think there was a request that if we can do a YAML level tutorial of the demo. So basically, I think it's more like a, yeah, or if there is an article which gets into more details of the Kubernetes YAML config, I think that would
Acha,
be
YAML.
helpful for configs.
Um,
Because I think that's isn't that what you're talking about, that a YAML level tutorial of the demo.
Yes. So basically, we just saw the demo, how the things are getting done there, but how to set it up. So if we can get something insight about that, that'll be good actually.
from the harness perspective, you are
No,
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 meaning.
from
from the
Kubernetes, which you just explained basically. So basically,
That is that I have already posted on my Twitter handle. So,
oh,
uh,
okay.
so that's what I mentioned at the start. Though I
yeah,
mean,
yeah.
I did post two set of
Yeah,
things
yeah, and
for
I've shared it with
specific.
the audience. I'll share it once again. I've already shared it with the
Yes, two
audience.
set of things, because one
Yeah,
set was from previous session. There was a question on couple of tool sets which was
monitoring
required
and debugging.
for
Yes,
monitoring
yes.
and debugging. So I have posted that as well. And from the deployment perspective, I have actually mentioned that it's it's pretty simple and very straightforward. If you open that document, right, you can see the steps are already there, and you can. It's nothing but we did that demo last time. In fact, for first time rolling out, if you want to update this rolling out, all you need to do is to change that image tag name. So I did show that YAML file and the image which I was showing you, right? I just need to change that image, and if I change that image to version 2, if I'll share my screen and I'll just show you that as well. Uh, just give me a minute, something. So let me show you this. So here, right, this is the version of Redis, version 1 of Redis, or okay, let me show you an example. Version 1, okay? This is your version 1 of your front end. And now you want to go and do a deployment version 2. That's it. So that's the update of the version 1. So version 1 gets replaced with version 2. So all I need to do is to build a container, create a version 2, and we did that last time when we did the container example, and we deployed that in the registry with this was our registry path as well, if you remember from that demo. And when you connect that to version 2, it becomes version 2. So it's the similar way you have to deploy, and the service part of it. And if you go to that document, how you have to define the service is also available. So it's explaining cleanly, and it is really good document actually.
So this is something like Kubernetes scaffold, right?
Yes.
Okay, sure.
So if you go, I actually the main reason why I posted that in my Twitter handle as well, too, so that you can easily go through the steps and test it out, because it is done on an Nginx deployment, and it is very easy to understand, and how exactly the different kubectl commands they are using to change the record, to set the image while the image is running, and also status, checking the status of that specific file, and then how you can use the deployment description command. So as I told you, it is only kubectl and YAML file updates. So these are the only two places where you're going to use it, and you can easily see that it's a nice document. In fact, it has a very good examples of testing it out.
Okay, that brings us to the, I think though we don't have any more questions